Hello everyone, here is the video presentation of EEMT 5120 Operation and Production Management. We are a team of 5 people, Joyce, Caesar, Omer, Hossein and myself Dennis. We have focused our study on the beer distribution game. As you may not be familiar with this topic, we will on the first part talk about some history facts concerning this game. We will also give the rules of the game, and finally, we will highlight what assumptions have to be taken into consideration for the following analysis. The second part of our presentation will show the actual simulation we made with 2 cases. Finally, we will discuss about the result the simulation has given to us. Let's start with the first part. The beer game is a simple simulation of a make-to-stock supply chain created by a group professor at MIT Sloan School of Management in the early 60s. The purpose of this game is simple: provide a playful yet serious way to experience typical coordination problems of supply chains and demonstrating a number of key principles of supply chain management. In more general terms, the supply chain represents any non-coordinated system distributing a single item, in this case, cases of beer. How to play this game? There can be up to 4 players, each assumes the role of a company. Each company is the supplier or the customer of the other company. And finally, the object of the game is to minimize the total cost for everyone by maintaining lowest stock possible while managing to deliver all orders. The results are generally shown in charts, and the result here that matters is the total cost of the supply chain, meaning that if one player is trying to reduce his own costs at the expense of the others, this will be a bad behavior. What companies are we talking about? In other words, what role can the player have in this game? Let's see that on the game board. The companies are the factory, the distributor, the wholesaler, and the retailer. Here is how it should be looking like on the game board. The factory brews beer from the material he ordered, and then he places orders to get the raw material. Distributors make orders to the factory, and beers get shipped from the factory to the distributor. The process is very similar for the remaining participants, and eventually, the customer gets his beer after the retailer has received his orders from the wholesaler. This is the most traditional supply chain functionment, and the operating process is very simple. Every company can either ship beer, order beer, or manage inventory. Then let's move on to the following assumptions that were made to mark out the boundaries of our work. First, the demand is variable. Then there is no capacity limit to the inventory and backlog of each company, and there will be an initial inventory to each company which will satisfy the incoming order. There is no information sharing between each other. It means that only the retailer knows about the market demand. Others can only forecast demand according to the order placed by the closest downstream company. For instance, distributors only know the demand of wholesaler and place their order to factory based on such information. Lead time. It means that there will be time lag between placing order and receiving products. In the game board above, the lead time equals T1 plus T2. We assume the lead time to be the same between every 2 companies. To simplify the model, we just take holding costs and shortage costs into account. Finally, satisfy backlog. Even though we do not have enough product to satisfy the order from downstream company immediately, we have to order products and compensate this backlog later. Now let's dig into detail for the operating process. Every company in this supply chain has the following operating process in every period. First, they receive products from upstream, in other words, these incoming goods. Then they're shipping products, meaning the outgoing goods, according to the order from downstream. They will have to manage the inventory and backlog, as we said before. But most importantly, they will have to forecast demand based on order from downstream company and place order to the upstream company according to our prediction and inventory situation. Now, we can move on to the second part, the simulation.
Based on the existing game introduced in the first part, we simulate our game based on several rules. First, we define the holding cost is $1 per unit and backorder cost is $5 per unit. To make our game more realistic, we add another factor, selling price, $2 per unit. Since it's constant, it won't affect our inventory and order strategy. Besides, another critical factor is lead time. We define it as 2 weeks. It means that the time since we place our order till we receive our products is 2 weeks. To simplify our game in the supply chain, we choose to act as a factory. The main difference is that there will be no delay to our ordering products. Now, let's introduce our game players. There are 2 teams playing simultaneously. The only difference is the ordering strategy. Team A will explore their mind and decide by human perception. Team B will employ math model to forecast the demand and decide the number of the orders. In this way, we can determine the effectiveness of our forecasting model. This is our game surface. Both of the 2 teams will play game on it. There are 2 games. The difference is the trend of demand. In the first game, the trend is exponential increasing, and the second one is seasonal trend. And there are 25 weeks in each game. Every week, CISA will announce the demand according to a random number generating program. Besides, each team will receive beer from upstream company and then ship beer according to the demand. Then, the game program will show the inventory and backlog state, cost and profit automatically. Based on the state and their forecast, they will place an order. To avoid being affected by too many other factors, we require each team decide the order in 20 seconds. Understand the rule of our game? Let's start. This is the tentative demand for current period. Team A and B will place their order based on the trend, but the trend will change until actual demand of each week is determined.
$493.
That's great.
So 77 more. 804.
No, it's not like that. Oh my god! What is
Now, let's look at the game result. In the first game, Team A got final profit of $29,000 and the profit of Team B was $35,000. Besides, Team B also won Team A for $1,000 in Game 2. Congratulations to Team B, won both of the 2 games.
Let's start the managerial insights. First, we will take the Team B of the exponential trend, and we can see from the profit graph of the Team B there's few interesting things noting in the profit graph. The first is like that we have an initial inventory of 10, but in the start we get an order of more than 10, so we have to start in the backlog, and our profit decreases in the negative values, and the backlog continues till week 3 until we get our orders. Then we start to grow in the profit from the week 5. Due to lead time of 2 weeks, our loss continues. We cannot fulfill our demand. But in week 5, our profit goes into positive numbers, and we can receive a big order in week 2 like that. But you can see a strange thing that in week 7 and week 17, both the profit slumps. This is because to the variability in the demand. The demand got quite a high value in week 7 and week 17, which a formula, which a software cannot cater for, cannot predict. So we had a slump in profit. Otherwise all our values are in profit again. Let's see the profit graph of the team A of the simulation of exponential trend. The team A also gets in a negative number in the start because they also had a backlog from the start because the initial inventory is only 10 and the orders demand is the same. And they also went into profit in week 5 after they get the supplies in week 3. But the interesting thing in team B is to note like when team A got in a loss in week 16 and 17, while the team A profit rose in that period. The reason for that is because the software cannot predict that change, but the human prediction can be changed very fast. As they were taking help from the past data prediction, so their change went good. Another reason for that was the human behavior. Team A knows the backlog cost is more than the inventory cost, so they can account order more. But the software cannot predict the backlog cost is more as compared to the inventory cost. So that's why overall in week 16 and 17 team A got into profit. But if you compare the overall profit of team A and team B had a greater profit than team A. Okay. Now we can start the managerial insight of the Winters method, the seasonal method. We will start first with team B and see the profit chart of the team B. You can see, as I said before, we had initial backlog from start, as initial inventory was 10 and initial order was 39. But again, we had a lead time of 2 weeks, so backlog continues and our profit decreases and goes into negative. But from week 5, we had a sharp increase in profit due to as we ordered a huge quantity in week 2 and 3. But you can see that in week 9 and week 16 and 24, our profit slumps a little bit. This is because it has seasonality of 8 periods, and after 8 periods, the season again starts and the initial inventory is low, order is low, but we had an initial inventory of greater than the order, so we had a negative of keeping an inventory, negative cost of keeping an inventory. Otherwise, all the graphs show that we are in profit. We increase the profit from week 9 to 15 and from 17 to 21 as the software can predict easily the trend. Let's see the profit margin of team A. The team A does not use the software to predict the demand, but they use the demand of the previous years to see. Although there is not that much difference in profit between team A and team B, but there are many interesting and many insights we can see from team A. They had the same backlog till week 3 and their profit increased from week 5. But there is a very amazing trend in them. Just before the new season starts, when team B starts profits to decline, their profit gets to a sharp positive incline in week 8 and then a very sharp decline in week 9 and week 10. The reason for that is because they ordered nothing in week 6, seeing the start of a new season, in the start of new season demand would be low. So their backlog increases a lot and which get that into loss. This software takes care into account. The same trend occurred in week 16 and week 24 But overall team also cater for trend and seasonality factor, but they could not remove the noise factor that good as the software did.
Seeing the demand order charts, we find that the order of Team B has a very good similar trend with the demand, while Team A had more variations in order numbers. In many weeks, the deviation of order with demand is pretty large, causing big inventory cost. Since there are 2 weeks of lead time, the order should be enough to fulfill the demand in these 2 weeks. In seasonal trend, the effect is more serious. Due to the lead time, the company cannot respond to the change of demand immediately. But again, Team B placed orders with similar trend as the weak demand, which cost them less than Team A. So, what is the successful strategy that helped them to win? First, they employed the exponential increasing and seasonal forecasting methods learned in class. What's more, they take the lead time of 2 weeks into the forecasting model. Actually, the backorder and inventory cost can also affect the ordering strategy. Like in our game, the inventory cost is $1, while the backorder cost is $5. It means that it will cost less to have inventory than backorder. If we swap the two cost figures, then they tend to have backorders than stock products. So from the assumptions we introduced in the first part of our game, we find that the lead time and information limitation have put more pressure and trouble in responding to the demand change.